Welcome back. Today we're going to be taking a look at severity number 3 in the OWASP top 10. That will be sensitive data exposure. Let's go to the introduction. When a web app accidentally divulges sensitive data, we refer to it as sensitive data exposure. This is often data directly linked to customers. Example would be names, dates of birth, financial information, etc. Could also be more technical information such as usernames and passwords. At more complex levels, this often involves techniques such as man-in-the-middle attacks, whereby the attacker would force user connections through a device which they control, then take advantage of weak encryption on any transmitted data to gain access to the intercepted information, if the data is even encrypted in the first place. Of course, many examples are much simpler, and vulnerabilities can be found in web apps, which can be exploited without any advanced networking knowledge. Indeed, in some cases, the sensitive data can be found directly on the web server itself. The web application in this box contains one such vulnerability. Deploy the machine, then read through the supporting material and the following tasks as the box boots up. Task 9. Part of the OWASP Top 10 series, and we're going to be doing sensitive data exposure. The lab's already been launched, so let's get into supporting material number 1. Most common way to store a large amount of data in a format that is easily accessible from many locations at once is in a database. This is obviously perfect for something like a web application, as there are many users interacting with the website at one time. Database engines usually follow the SQL or structured query language syntax. However, alternate formats such as NoSQL are rising in popularity. In a production environment, aka an enterprise, it's common to see databases set up on dedicated servers running a database service such as MySQL or MariaDB. However, databases can also be stored as files. These databases are referred to as flat file databases, as they are stored as a single file on the computer. This is much easier than setting up a full database server. Accessing a database server is beyond the scope of today's task, so we're going to focus on flat file databases instead. As mentioned previously, flat file databases are stored as a file on the disk of a computer. Usually this would not be a problem for a web app, but what happens if the database is stored underneath the root directory of the website? Example would be one of the files that a user connecting to the website is able to access. Well, we can download it, query it on our own machine with full access to everything in the database. Sensitive data exposure indeed. That's a big hint for the challenge, so let's briefly cover some of the syntax we would use to query a flat file database. The most common and simplest format of flat file database is an SQLite database. These can be interacted with in most programming languages and have a dedicated client for querying them on the command line. This client is called SQLite 3 and is installed by default on Kali. Let's suppose we have successfully managed to download a database. We see a picture here. SQLite demo, the ls-l, the list all, and below we're seeing read write access for Murray. And then we see the file example.db, and this is basically what the example is the text is talking about above. We could probably just download this, query it, and then we'd have information that we need. But let's continue reading. We can see that there is an SQLite database in the current folder. To access it, we use SQLite 3 followed by the database name. Example below with a picture, SQLite 3 example.db. They're now brought to the DB. From here, we can see tables in the database by using the .tables command. Boom, found a customer table. At this point, we can dump all the data from the table, but we won't necessarily know what each column means unless we look at the table information. First, let's use pragma table info customers to see the table information. Then we'll use the select query from customers to dump the information from the table. We've got pragma table.info customers, and list of customer ID, customer name, credit card, password, and then we can query this, select from customers. And we have Joy Paulson, John Walters, Lena, Andrew Miller, Keith Wayman, Annette Schultz, followed by a little bit of hash here. We can see from the table information that there's 4 columns: customer ID, customer name. I just read that, so it's fine. We have customer ID 0, customer name Joy Paulson, and then we have the credit card number here and a password hash. The next table will look at cracking this hash. Read and understand supporting material on SQLite databases. Let's go ahead and click complete. And we'll move on to task 10, which is going to be the practical example of sensitive data exposure. In the previous task, we saw how to query an SQLite database for sensitive data. We found a collection of password hashes, one for each user. In this task, we will briefly cover how to crack these. When it comes to hash cracking, Kali comes pre-installed with various tools. If you're not familiar with cracking hashes, if you know how to use these, then feel free to do so. However, they are out of the scope of today's material, as this is basics of OWASP Top 10. Instead, we'll be using the online tool CrackStation. You can access this via Google, whatever web application you decide to use. This website is extremely good at cracking weak hashes. For more complicated hashes, we would need more sophisticated tools. However, all the crackable password hashes used in today's challenge are weak MD5 hashes, which CrackStation should handle very nicely. When we navigate to CrackStation here, we can see basically you'll enter the hash here, run it, and it supports LM, NTLM, MD2, 4, 5, SHA-1, 224, SHA-256, and etc. Try pasting in the password hash for Joy Paulson, which we found in the previous task. Here, 5F4DCC, blah, blah, blah. We solved the CAPTCHA, then click the crack hash button. It's going to give us some plain text here. We see that the hash is successfully broken and the user's password was password, very secure. It's worth noting that CrackStation works using a massive word list. If the word list is not in the word list, then CrackStation will not be able to break the hash, and we're going to have to use other tools. But again, that's beyond the scope of today's lesson. Challenge is guided, so if CrackStation fails to break a hash in today's box, you can assume the hash has been specifically designed not to be crackable. Answer the questions below. Read the supporting material about cracking hashes. Click complete. Let's move on to task 11, severity 3. Sensitive data exposure, and this will be the practical challenge. Alright, it's time to put what we learned into practice. Have a look around the web app. The developer has left themselves a note indicating that there is sensitive data in a specific directory. Now, if you're working in an enterprise environment, or you're in charge of a team of developers, or you're a liaison between the security folks and the developers, what you're going to want to do is make sure that you scream at your developers and tell them that they should not be leaving comments like this anywhere, because it's extremely unprofessional, number one, but also it's just bad coding practices. What is the name of the mentioned directory? So I don't know if we're going to need the hint, so let's just try to do it without the hint so far. We'll go ahead and find the IP address. Maybe we'll give it a here. Have a look at the source code on the login page. Alright, so I believe 10.10.219.175 should get us there. Let's go ahead and type that in. 10.10.215. I can't even remember it, but whatever. 10.10.219.175. 175. Welcome to Sense and Sensitivity. You've reached the future world #1 in all things therapeutic. We are a startup organized based in Taupo, New Zealand. Our location near the stunning Lake Taupo lends itself perfectly to our ideology. All mental maladies are curable, you just need to know how. We draw a great deal of inspiration from the genius of Jane Austen, whose great work serves as a beacon from a simpler time. While we are currently still in our beta phase, our aim is ultimately to work with people who are struggling, to learn with them as we work together to combat the dangers of poor mental health. We aim to provide a safe and peaceful environment for those who need it. For the time being, we are only accepting beta testers of the program, so please contact us here. If you feel like stay with us among some of the most beautiful scenery in the world, it would be beneficial to you. So let's go ahead and click on this and see what it is. We'll use Google, open the link. Alright, so it's providing like a Google sign-in. So this is out of the task, or out of the scope for the task. However, we're going to go to the login page here, as they mentioned that in the hint. We have a regular login. And since we're looking for sensitive data exposure, we're not going to try any other techniques. And we're just going to view page source here. Alright, looking at the code. Got some regular HTML stuff, some CSS, and then below we see a comment. Must remember to do something better with the database than store it in the directory of assets. So let's go ahead and take a look at the directory of assets. Now let's go ahead and delete the login here. Okay. They've made it very simple to understand what's going on. So basically this assets directory is listing all of the assets for the web application. And luckily for us, makes it easy. We don't really have to search much. The webapp.db is right here on the bottom. And clicking on it, we've now just downloaded the DB. As mentioned before, SQLite, it comes pre-installed on Kali, so here it launches the database for us. We don't really need to use command line to query anything. I believe that's the answer to the first question, so let's go, what's the name of the mentioned directory? And that would be -assets. Question 2, navigate to the directory you found. And question 1, what file stands out as being likely to contain sensitive data? Now we've got two tables here. Not going to let us make it bigger, but it really doesn't matter. We have sessions and users. The sessions is going to basically have session ID, user ID, and show when the basically when the login of the session expires. Like you could set times. In order to combat things like this, you would probably want 15 minutes or XYZ, depending on basically the security access controls or kind of the rules put in place by your organization. But however, I think it's users would provide sensitive data here, as we have user ID, username, password, and admin in plain text right here. What file stands out likely to contain sensitive data? Probably the password. that's not it. Maybe it's users. What file stands out? It's going to end up being sessions. We're going to head here. Navigate to the directory found in question 1. What file stands out? This is the name of the DB. So if we were to look here, index of assets directory, we have webapp.db. Type that in. Whoop, whoop. Let's move to question number 3. Use the supporting material to access the sensitive data. What is the password hash of the admin user? So here, since we've already launched the DB, we want to go to admin here. Click on this. And where you can see the SQL log here, it doesn't look like there's much in there. If we go in the edit database cell, maybe it's going to allow us to edit and take a look at the hash here. So let's try to do that without having to use CMD basically. Now, how are we going to do that in this little application? I am not sure, so we're going to have to find that out. I have no clue how to figure this out inside of this webapp.db. We'll just use command line and be much easier, and it will also follow along a little bit better with the write-up. So at this point, we're going to want to CD into the downloads. So let's just go into LS here real quick. CD, downloads, LS again. And we have the webapp.db. Now let's find the command here that they provided for us. Alright, so scrolling up a little bit here, we have SQLite followed by database name. So we'll do SQLite 3 webapp.db. We're now in the database, and then I believe we can do .tables to list tables. We have sessions and users. Now, the question asked us what's the hash for the admin, so we're going to go into the users. To do that, we're going to need that pragma command and then select from customers here. So pragma table info of users. So pragma underscore, and we may not even need this. We could maybe just actually select from customers, but let's try to follow along and see what happens. Table underscore info, and then what is it? Users. So we have user ID, username, password, and admin int1. Yep, so at this point we'll select from star, and then we'll say users. doesn't like that, so that's fine because the syntax is wrong. It's okay. I don't really spend all day in SQL, but anyway, select star from users colon, and we have a couple of hashes here. Now we have admin here, Bob and Alice. So the first one is their credit card, I believe, and the second is going to be the hash. Let's copy the hash. Then we'll go ahead and paste the hash in here, click submit, and that is the third question answered. Now it's asking us to crack the hash, so we'll go to Google and use CrackStation to do so. Google.com, accept all their cookies, CrackStation, be the first link. We'll paste the hash in here. I'm not a robot. Verify and crack hashes. And we've cracked the hash of MD5, and the result is QWERTYUIOP. So QWERTYOP will be the password, and that is the plain text password for the admin. That is also the answer to question number 4. Click submit. Now it's asking us to log in as the admin, find the flag. Let's go ahead and do that. Now, how to log in, we're going to go to the web application here. So, we'll type in admin, we'll type in, actually I'm just going to paste it because I really don't care to type it in incorrectly. We'll log in, and well done. Welcome, admin. Your flag is THM, YZC2Y, blah, blah, blah. Let's take this here, copy it, and that is the last question answered. We'll click submit, and that is the end of today's lesson for sensitive data exposure. If you like that, please like, subscribe, and comment for more, and we'll be continuing with the next task in the next video. Thank you.